Morning, Shane.
Morning.
Morning, Spencer. So this time, if you're logging into Pear Deck, if you go to joinpd.com, you'll probably just be given an option to click on our class rather than having to type in the code. If that doesn't happen, you can still type in the code, but I'm trying a shortcut.
Oh, it
Give us
worked
a little
this
bit.
time for me at least.
Did it work for you, Larry?
Yeah.
Okay, good. It's a feature they give to all the teachers who have, I don't know what they call it. What do they call it? All access accounts, premium accounts. So trying something out. Good morning, Nava. Morning, Kathleen. Jenna, good morning. Here comes everybody fast and furiously. Phoebe and Olivia and Anna, good morning. Good morning, everybody.
Good morning.
When you go to joinpd.com, you might not have to enter the code. You may just be able to click right on our class just to save you an extra step. If that's not working for any reason, you can still enter the code that you see. I think time is going to be of the essence as we return to normal on Monday. So I'm trying to streamline things if I can. I missed you as you came in, as I let you in. Good morning. It's nice to see your faces. I think I'm actually going to be able to see your faces, or half of your faces, starting on Monday, at least temporarily, perhaps. Things are popping up in the chat. Sorry about that. I missed it. Get some flash notifications here. All right, folks. I think we got just about everybody. And if you're just joining us, I'm trying to streamline the Pear Deck access. So when you go to joinpd.com, there might be just a drop-down menu where you click our class. Maybe other teachers are already using that. I'm not sure. Just to kind of streamline things, because whether you plan to come back to school next week or not, we've got a whopping 45 minutes together, and we want to make use of all that time. And on that note, before we get started, my plan today, maybe tomorrow, but hopefully today, is I want to make a video for you that will kind of walk you through, if you're going to come back to school on Monday, what that will look like for our classroom. Because honestly, you've never been here, right? At least not in this room. So I want to kind of give you a sense of what the procedures are going to look like. My understanding is that the administrative team, our principals, are going to share like a Google slide deck with you about the procedures. But let's be honest, how many of you use email as your primary form of communication? And if you do, how many of you are going to watch a Google slide presentation by a principal? So I wanted to make something that you could watch. It'll be really short, 3 or 4 minutes tops. And hopefully that'll relieve some of the anxiety that may be associated with coming back. I mean, I'll be very honest with you. I am ridiculously anxious. I am afraid. Yesterday, the numbers hit 12.1%. That sends shivers through my body. So I am not going to pretend that I am not nervous, that I am not scared. But if I can act to relieve some of that, both inside of myself and for you, that is what I'm going to strive to do. Okay? And we're going to ride this out for as long as we can. I said from the very beginning, we're in this together. So my hope is that we can continue to do that for as long as we can. All right. Are there any questions about coming back to school? Or if you're choosing to stay at home, of course, that's okay too. That I can answer right now for you. Well, let's take a look at the plan for the day. So we have our return to in-person learning, albeit in a hybrid model. We have the undetermined results from a national election that are still hovering over our heads. I don't know about you, but I am pretty anxious, pretty tense this morning. So I thought we could do something this morning that might act to alleviate some of that. It's called a body scan. It is a form of contemplative practice, but it's a way to maybe relieve some of that tension, anxiety, and fear that we might be feeling right now. So I thought that's where we could start. And then I've got really a bunch of practice problems for us to look at today that connect to the learning that you did asynchronously away from me this week, but also even going back to last week on food webs, interspecies feeding relationships, ecological interactions, and the movement of energy through a living system. So lots of practice problems, and really they're intended to support and reinforce the learning that you've done away from the classroom. And of course, we'll end with our traditional exit slip, or as close as we can get to it. All right. Before we get started though, is there anything that I can do to make your lives a little bit easier, a little bit happier? Okay. Well, if you're interested in relieving some of the tension, anxiety, fear, contraction that you might be feeling, or if you're not experiencing any of those things, that's okay too, and you're willing just to try something new, I would once again encourage you to find a position, a seated position where you can be as comfortable as you can be. Again, I kind of call this comfortable but confident, upright but relaxed. And I would ask you first just to take a deep breath in, and then a deep breath out. And just allow yourself to sink into your seat a bit. And feel that you're sitting. Know that you are sitting. And you can close your eyes or leave them open, it doesn't really matter. And we're gonna begin this body scan just with our feet. We wanna notice our feet and how our feet are feeling right now. And as you breathe, if you can just let your feet relax and imagine that they could sink into the ground by like half an inch. Just let go of it. And then notice your legs. How are your legs feeling right now? And just like with your feet, just let go of your legs and let them sink either into the ground or into your chair, maybe even into your bed, depending on where you're sitting. And then notice your hips. Sometimes we hold tension in our hips without even knowing that we are. So notice your hips, and again, I'll just allow yourself to sink just a little bit more deeply into your seat. And know that you are sitting. And then notice your belly. We often hold pressure, contraction, tightness in our belly. If you notice anything this morning, just let go a bit. Maybe notice if there is contraction, that around the contraction there's openness. And breathe into that openness. And then bring an awareness to your shoulders. Maybe let them drop a bit, especially on the exhale. Just allow them to drop. And you can wrap around to your neck. Even kind of move your neck back and forth, turn it a little bit, move it side to side. Just allow it to relax. Release any of that tension that might exist. And then finally, just notice how your whole body feels right now. And just like when we began, take one more deep breath and allow your body to sink into your seat. And know that you are sitting. And whenever you're ready, you can wiggle your toes and wiggle your fingers. If you had your eyes closed, you can open your eyes slowly. And just bring yourself back into whatever space you happen to be in. Notice if you feel different. You can do that anytime that you like. But I hope that you found it helpful. I'd love to know either in the chat or with a thumbs up, thumbs down, intermediate thumb. Was that helpful this morning? Of course, if you didn't do it, that's okay too. It's not required. We're just playing around. We're experimenting. Serenity and equanimity. I often wonder if that is part of our lives. I often feel like it's missing from mine. So paying attention to when it's not present, bringing myself back and allowing myself to experience it, I find to be very helpful. So I hope it was helpful to you as well. All right, folks. Like I said at the beginning, today's really all about practice and making connections to the learning that you've been doing away from our virtual space. So to start, I've got a practice problem. You can think of this as, again, a practice AP free response type of problem. So give yourself an opportunity to read the background information, read that paragraph, take a look at the figure, make sense of it to the best of your ability. If you have clarifying questions, of course, that's what I'm here for. And then when you're ready, you can start typing your answer. I will say for this question, there are two parts to it. So I will give you control over the slides so that you can answer these two questions at your own pace. Okay. So the responses are starting to come in. Again, I'm here for clarifying questions. If you're uncertain, you don't have to struggle in silence. Chat. Your voice. Did you know that you could vaccinate wildebeest? Who knew, right?
Wait, I'm a bit confused. Wait, so are the colored end circles the ones that have been vaccinated?
So we don't necessarily know that they have been vaccinated. I think it would be realistic to infer that they have been. The colored in circles, the shaded circles, right? They're in reference to the left y-axis, right? Where the number of wildebeest in thousands has been measured over the course of time. And in many ways, right, this is the result of counting the number of wildebeest, it looks like by decade or approximately by decade over the course of time. But it would be fair to infer that when they vaccinated or started to vaccinate back in, what do we have? Because it began in the 1950s, right? That they didn't stop doing that immediately. There certainly could have come a point where that program ended once they determined, the scientists determined that this particular viral pathogen that caused the rinderpest illness had been eradicated from the population, which is probably around 2010, 2012, right? The last sentence of 2011, the UN decided that this vaccine program had been successful. It probably continued, in other words, from the 50s right up until around 2010, 2012. So remember, there's two parts. There's the first part and then the second part. Obviously, the second part connects to the case studies that you were looking at. And if you'd like, on the next slide, there is an image of the Serengeti food web, if that's helpful to you. So on slide 96. Mm. Lots of good thinking is coming out in your answers. Good analysis. Really nice. And of course, it's okay not to be sure, right? All right, so just to check in, how much more time do you need to wrap up your answers to these two questions? With finger minutes or in the chat, either way. And remember, a fist is 0, it's very helpful to me. Those of you who have your camera off, just typing in a quick number into the chat. 1, 2, 3, 4, 5. Probably not 5, but it also helps me know that you're there. How much more time do you need to answer these two questions? Okay, seeing lots of 0s and 1s, so just a little bit more time to wrap up. Thank you for those of you who are entering your numbers into the chat. Okay. Would you like to go over any of these two questions, either of these two questions? Or you want to move on to something different?
Can we go over number 2, predict whether the effect of the virus causes the rinderpest disease?
Sure, absolutely.
Overall.
Absolutely. So just quickly then, on number 1, I saw a lot of really, like I said, a lot of good thinking that the vaccination program was successful, right? Even notice I titled this part of our lesson today. You can go back if you'd like. I'm going to have to go back anyway because vaccines are great, right? Right. We still in this country have this notion that like vaccines are dangerous, that they don't work, that they cause harm, or I don't need one. I don't get sick. Wow. We could unpack all of that probably over the course of an entire week in a class like this. But of course, vaccines work. And if you don't know why they work, we could unpack that, albeit briefly, in a class like this. But for the love of dog, if you are not being vaccinated against the flu right now, it should be one of the first things you do. Tell your parents, tell whoever you live with, mom, dad, grandma, grandpa, aunt, uncle, whomever. We need to go to CVS today. We need to go to Walgreens today and get my vaccine. Okay, because they work, right? And we can see from the information like this, right? Not only do they work, they're super effective, and they led to a massive increase in the size of the wildebeest population in a pretty short period of time. And I saw that somebody had written, I'm gonna get my pen out here real quick. Somebody had written that because of the vaccination program, eventually the population of wildebeest even reached its carrying capacity, right? The maximum number of individuals that a particular environment could support. So that was a really good observation that I noticed in your writing. But to speak to the second question, which I'm hoping you are noticing connects to your learning outside of class, right? We're trying to predict, oh my goodness, right? Whether or not this virus is having a top-down or a bottom-up effect. And we can take a look at what you folks came up with. Go back a bit. Looks like top-down was the leading vote getter for something like this. And I would agree. It's most likely not bottom up, but it's tempting to say bottom up, right? Because we're talking about a virus. We're talking about a simple thing, and viruses aren't even alive. They're not living things. I did try to put an image of the virus on top of the wildebeest. I hope you can see it on your end, because that's the organism, right? The species that's being affected in this particular living system, within this particular food web. But it's not bottom up because the virus is simple, right? And it's not bottom up because the virus isn't affecting something that the wildebeest are feeding upon, right? If that were the case, then we could see, like, for example, if I go back, just to get rid of the virus image, right? If it were affecting the red oak grass, right? If the virus were affecting the red oak grass and it did harm to the red oak grass in such a way that the numbers decreased, then you could see how the wildebeest were being affected from a bottom-up perspective, right? There's no evidence for that happening here, right? And we've got to be careful, right? Because the virus is also not affecting the aardvark or the pangolin or any of the other things that, well, I guess in this case, if we're focusing on the wildebeest, what do we got? The hyena, or I guess that's it. The hyena appears to be the only species. No, I take that back. There are others that are up here as well. The serval is feeding off of the wildebeest, and the cheetah is feeding off of the wildebeest, and like the lion is feeding off of the wildebeest. So it's tempting to say top down in respect to, oh, well, one of those higher level predators, right? One of the organisms, one of the species at a higher trophic level is being affected by the virus. And as a consequence, there's an effect on the wildebeest. But there's no evidence for that either. The virus is specifically targeting the wildebeest, and it's doing harm to the wildebeest as a consequence. So it's tricky, right? I mean, the virus isn't feeding off of the wildebeest, but it is parasitizing the wildebeest. So in many ways, what we have to do, right? If I were to go back one more time, we've got to put that image of the virus like in a position in the system where it's not feeding on the wildebeest, but it's definitely doing harm to the wildebeest population, right? Now, upon the vaccination program being initiated, that harm was initially reduced and eventually eliminated over the course of time. But at least during that time period where the virus was able to exert its effect, it was exerting its effect in a top-down manner. That was a lot of me talking. What questions does that bring to light for you, whether it's about the wildebeest or the question or about viruses?
So, wait, no, I forgot my question.
Okay. I'm going to trust that if questions come up, you'll either put them up in the chat or you'll ask them out loud or send them to me by email or use Remind, whatever the case may be. But this seems like a good opportunity to take a break. So we'll take our 3-minute break. We'll come back and we'll do some more practice problems that hopefully will connect to the learning that we've done over the last week or so. Okay, I'll see you right about 9:30. people are already responding. We actually weren't going to do this one, but you're welcome to respond to it anyway. Right. We could start making our way back together. I hope you had a chance to get up and move around a bit, get a drink of water, use the restroom, pet your cat. Alrighty. I actually wasn't thinking about using the question on the screen right now, but some people have already begun to answer it. So if you want to start here with our next practice question, you're welcome to, and then we'll go on to a different one. I was afraid this one might be a little too simple. But since we've already got about, what we're up to now, 11 people who have responded, feel free to start our practice here. And then we'll see how people are doing. And just a reminder, the first question we did, that was an example of an AP free response question. This, of course, is an example of an AP multiple choice question. So everything that we're doing connects back to not only to our learning and to practice around our learning, but also to the AP exam. All right. Should we take a look at how people are doing? Looks like A is by far the most popular answer. And of course, now the answers are going to change, right? How easily swayed we are by peer pressure, right? But indeed, A would be the correct answer in this case. If I bring my pen out again. These would be the photosynthetic organisms, right? These would be the autotrophs, if we were to connect it back to one of the Edpuzzle videos that you watched. And this is, again, I thought this question was kind of easy, but one of the reasons why I do like the question is because of the location of the decomposers, right? And decomposers can come in many different forms. They could be bacteria, they could be fungi, they could be earthworms, or some sort of worm-like organism, an annelid, if you're familiar with that term. But one of the reasons why I love this question is, we often think of like fungi and bacteria as really simple organisms, right? That they would be at the base of a living system, that they would be at the lowest trophic level within a system. But in reality, if you look at a diagram like this, they're actually at some of the highest trophic levels, right? I mean, if we began to kind of think about if A was the producer, we might argue that if C's feeding off of A, that they're at the second trophic level, and that would put the decomposer at the third trophic level. But there's also the potential for A, the producers, right, the autotrophs, to be at 1, for D to be at trophic level number 2. But look at this, looks like B feeds on D, which puts B at the 3rd trophic level. And now all of a sudden, our decomposers are coexisting at 2 trophic levels, 3 and 4. But that ain't 1, and that's not 2, even though potentially, right, it could also be 2, right? They're also feeding off of probably the decaying remains of the producers in this particular system. So they're these incredibly important organisms that are part of most, if not all, living systems, but don't think of them exclusively as existing at the lowest levels. Consider the possibility that they're also existing at high trophic levels as well. Does that bring any questions up for you before we try a different question? It's awfully quiet out there. I hope you're doing okay. Well, you kind of answered that one by default. So let's go to a different one here. All right, try this one. Again, an AP practice multiple choice question. About halfway there. So this would likely connect to the second of the 2 videos, Edpuzzle videos that you watched on trophic structure and food webs and energy flow. It had been a little while since you've watched it. All right. Looks like most people are getting in there. Take another moment to make or select your best response. Let's see if we can watch them flip in real time, right? Yeah, it's E, right? It's gotta be E, because E connects to the notion, right, that within a living system, we know energy is entering more often than not, right? There are those pesky chemoautotrophs that were mentioned in that heterotroph versus autotroph video, right? But more often than not, we're talking about photoautotrophs. We're talking about producers that photosynthesize, and light energy enters the system at their level. But photosynthesis is not a 100% energy efficient process. Energy is going to be lost to the surroundings in the form of heat. It's invariable. It's always going to happen. Now, of course, the producers aren't only performing photosynthesis, they're also performing cell respiration, which is also not a 100% energy efficient process. So there's 2 contributing factors in our producers where no matter what, we're always going to lose heat to the surroundings. And that concept applies to every higher trophic level. We're always going to lose energy to the surroundings in the form of heat. And of course, the organisms themselves are going to use some of that energy for their own life processes, right? For their own survival ability, their own abilities to reproduce. So this is such an important idea, if I bring my pen out once again, that in reality, if we were to arbitrarily say that at the level of the producers, there's 100% of energy available within the system, within the food web. In reality, by the time we get to the next highest trophic level, this is kind of crazy, 90% of that energy is either used by the producers themselves or lost in the form of heat to the surroundings. Only 10% of the energy is actually transferred from one level to the next within a living system. And that continues as we move up. So if we move up to the third trophic level where the secondary consumers are, now, relative to what we started with, only 1% of that energy is available. And if we go up, in this case, to the last level in the diagram, we're down to 1/10 of that percent. So you want to add a fifth level? Go for it, right? We're going to be at 0.01% in respect to energy being transferred from the fourth trophic level to the fifth trophic level. And there are systems that have 5 trophic levels. There's no doubt about that. But there's not going to be a lot of species diversity at that level because there isn't a lot of energy to go around. And if there is a fifth trophic level, and let's say there's 1 or maybe 2 species, they're probably not going to exist in very large numbers because there just isn't enough energy to go around. This concept is referred to as the 10% rule. It's pretty hard and fast in living systems. Only 10% of the energy is transmitted from one level to the next within a living system. What questions do you have about this multiple choice question? Is this helpful? Thank you, Larry. Felt like we were away from each other for so long that I wanted to take some time today and both reconnect, but also connect what you've been looking at to some actual questions. So I do hope this is helpful. If it's not, please let me know. I'm not going to be offended. I'm not going to get mad. All right, let's try another one. Again, another practice multiple choice question from an AP exam. People have started to add their responses in. That's wonderful. Wish I could see your faces to know if you're having a hard time or not. But I fully understand if you can't turn your cameras on. All right, almost there. I think some people wait to see the results before they cast their ballot. All right, let's take a look. Primary consumers, right? The primary consumers would be the organisms that are feeding off of the autotrophs, right? Off of the primary producers within the living system. And in respect to numbers, you would expect that second trophic level where the primary consumers would be located, right? To be able to sustain the second highest number of organisms within the system, right? So again, this comes back to that 10% rule of energy transfer. When we get to the second trophic level, we still have 10% of the energy available at that level. And as a consequence, we can support the second largest number of organisms. But I'm also hoping you're noticing as you move up to subsequent levels, because less and less energy is available to those higher trophic levels, fewer and fewer organisms can be supported as a result. Okay. Alrighty. Let's try something a little bit more challenging. This is an AP free response question. I'm going to give you control of the slides once again. So read the question, study the data table up top, and then when you're ready on the next slide, you should be able to write in and draw in both the names of the species and the direction of energy flow within this particular system. And again, I'm here for clarifying questions to support you, just like I would if we were sitting in the same room. You can type your answers too if you want to use the text box. I know it can be tricky to use the pen. Yeah. Most people are starting with what they know. That's awesome. Yes, once you type something, you can drag the text box around. I can see what you're doing. I like it. So again, there's two parts to it, right? There's the typing in or writing in the species names. So where do they go in this diagram, this food web diagram? And there's the arrows that you want to draw in that show the direction of energy flow. And that, of course, is connected to the interspecies feeding relationship. What's eating what? So quite a few people have. Yeah, so if you're having a tough time, if you're struggling, don't sit in silence. Chat, take yourself off mute.
Alright. Sure. It's like the less the diet, like, or the amount that they eat the midges, like, say like the Helgamites or however you pronounce that, they like only like 10% of their um diet comes from midges. Would you put that at the top because, or like the highest one, or how do I say highest slot?
The highest
trophic
trophic level,
thing.
right? If we look on the kind of the y-axis, right, of the food web,
Yeah.
it has increasing trophic level. So, you know, if we're applying our understanding, right, I think I heard you say, your audio was a little muffled there, but I think I heard you say that the Helgramites are going to go on that top line, right? They're going to go at the highest trophic level. And we're justifying that, that choice, right, based on the fact that 10%, the Helgramites are using 10% or they're feeding off of the midges as 10% of their diet, right? So it would follow, we were going to talk about this before we signed off today, it would follow that if you're at a high trophic level, right, there isn't a lot of energy available to you at that highest trophic level. So as a consequence, you're likely going to have to feed from multiple trophic levels in order to acquire the energy that you need to survive. And if we look at the row, right, for the Hellgrammites, they're feeding off of stoneflies, midges, and caddisflies. Okay, so it would make sense, right, conceptually, that the Hellgrammites need to be at that highest trophic level because they're feeding off of so many different species that exist at their own lower trophic levels. That's the only way they can acquire the energy that they need to survive and to reproduce.
That makes sense.
And I will say, if you keep clicking through, you will find the answer to this question. I have composed an answer to this question, so you can check your own work if you're curious. Call it the scoring guide, if you will. It's on slide 108. I hope you can see that on your end. So if you find yourself trying to draw the arrows, remember the energy is going to move from the producers to higher level consumers. So if you find yourself drawing the arrows downward, right, that's probably a clue that the arrows are pointing in the wrong direction. Try to take a moment and draw in the arrows, right, to show the direction of energy flow. What you see on the diagram is not sufficient. So what was given to you on the template is not sufficient to answer the question in its entirety. You need to draw in your own arrows as well. A lot of you are starting to do that or have already done that. So thank you for taking the time to practice. Yeah. If you haven't taken the time to practice, push yourself a little bit. If you're having a tough time, you don't have to struggle in silence. Even if you set the intention to come into learning support later on today, from 2 to 3, asking your questions, that's okay too. Would it be helpful to go over this together before we sign off? Thumbs up, thumbs down, thumbs up. Yes, I want to go over it. Thumbs down. I'm ready for the exit slip. Thank you, Shane, for changing your answer. And if I don't hear from you, I don't know what to do next. I want to be responsive to your needs. So if you'd like to go over this question quickly, we can do that. If you're ready for the exit slip, you can give me a thumbs down. In the chat, you could write yes. Yup, thank you, Jalen. Kaya, thank you for your thumbs down. Take you out of student mode real quick. So this is the correct answer to the question. This question is, again, it's a released item from an AP exam, and it was such an important question in the year that it was administered that the College Board has literally written to teachers to communicate with us, hey, when students took the test, they didn't know how to do this, right? And one of the things they didn't know how to do was draw the arrows. So as I was kind of scrolling through your answers, I noticed the placement of the species was spot on. You had algae as the primary producers, right? You had midges and caddisflies as your primary consumers, so that's your second trophic level. The stoneflies are kind of precarious, right? Because they're existing as secondary consumers. They're feeding off of the caddisflies and they're feeding off of the midges, right? But that tells us something, right? If they have two sources of prey, right? Two sources of energy, well, they're at the third trophic level. Not a lot of energy was being transmitted to organisms at that third trophic level. So it makes sense that their feeding relationships have evolved in a way, right, where they're feeding off of two different things. The role of natural selection is still really powerful here. If there isn't a lot of energy being made available to those higher trophic levels, organisms that have, right, that aren't picky eaters, if you will, are going to be favored over the course of time, certainly over picky eaters that are only consuming one source of prey, okay? And then by the time you get to the Hellgrammites, to speak back to Larry's question from before, they actually have three sources of food, right? They've got the midges, they've got the stoneflies, and they've got the caddisflies, which makes sense because at that highest trophic level, not a lot of energy is being made available. So they need to feed on three different sources of food in order to acquire the energy that they need to survive. Okay. So I'm hoping this practice today was helpful to you. There are other practice problems that are in here, but our exit slip is really easy. It's to drag your dot. So as you think about your understanding of food webs and trophic cascades and these interspecies feeding relationships, how would you assess your understanding of those ideas, those concepts right now? And as soon as you've dragged your dot, you are welcome to sign off, and I will see literally some of you on Monday. I'll see all of you on Monday, I hope, but some of you in person.
Thank you.
You're welcome.
Thank you.
Bye.
Bye.
Yeah.
Well,
Yep.
Oh wait, before I leave, did we talk about the asynchronous, what we did on the asynchronous learning thing?
you can, it depends on which one you did, right?
Oh, I just had this question. For the Midwestern Lake, would that be a bottom? Wait, is that bottom up or top down? Because
I would have to go back and look at it myself. I don't have them memorized, but I can do that if you'll give me a chance.
it's the one about the base fish, the minnows, and then yeah, there's the crown axe right there.
I did them all before I asked you folks to do them, but I certainly don't have them memorized. So let me pull them up real quick. Oh, that's next week. Let's see. Oh, lake. Come on, buddy. Midwestern Lake. So if you're asking about the removal of the bass, right?
Yeah.
Yeah, so if we're removing the bass, as we look at the diagram that's given to us, that's what I just did. I pulled it up on my own device. The bass clearly are the highest level consumer, right? They're at the highest trophic level. So if we're removing them from the population, that's got to be a top-down influence.
So were most of these top down? I feel like the Arctic tundra and the Midwestern Lake were both top down.
I think
Because-
you had the choice, right, of the four, to
Mhm.
choose two of the four. So it really depends on which two you chose. But yeah, I think those two in particular are top-down trophic cascades.
Oh, okay. I thought maybe I had missed something and that one of them was falling off. But
Yeah.
okay.
And really, it's all about practice, right? So if we're removing a high-level consumer, or really any organism from a higher trophic level, we're investigating its effect downward through the system. Now, if we remove a lower-level consumer, or maybe even the producers, and there is at least one example of that of the four, then that's got to be a bottom-up influence because we're going to alter the way energy moves through the system in an upward manner as a result.
Okay. All right. Thank you.
You're welcome.